Hello students, welcome to lecture 7 of hydrogen and its compounds. In previous lecture already we discussed about soft water and hard water. So what is the soft water? The water which produce good lather with the soap called soft water. Means in that soft water there is no calcium magnesium salts. And next to hard water. The water which not produce good lather with the soap called hard water. So in that hard water there is a calcium magnesium salts. Due to that salts, the hard water will not give good lather with the soap. And hardness of water is two types. One is the temporary hardness and the second one is permanent hardness. So temporary hardness is due to the presence of bicarbonates. Due to the presence of bicarbonates of calcium and magnesium. And the temporary hardness removed by two methods. One is the boiling method and the second one is Clark's method. And next one, permanent hardness. Permanent hardness is due to the presence of sulfates and chlorides of calcium magnesium salts. And this permanent hardness removed by four methods. Number one, treatment with washing soda, and number two, Kalgan method. So these two methods are completed in previous lecture. Now the third one, ion exchange method. This method is also called geolite. Geolite or permuted process. Permuted process. So this ion exchange method also called geolite or permuted process. And the hydrated sodium aluminium silicate is called geolite. The formula NaAlSiO4 XH2O. It is called geolite or hydrated sodium aluminium silicate. X moles of H2O molecules. So hydrated sodium aluminium silicate is called geolite. Simply it written as NaZ. So NaZ is called geolite. So this geolite is useful to remove the permanent hardness of water. So this geolite can remove the calcium +2 and magnesium +2 ions from the hard water. We know that there is a calcium +2 and magnesium +2 ions in the hard water. So from that hard water the geolite can remove that calcium +2 and magnesium +2 ions. Then the hard water become soft water. And during that process the geolite will be consumed. To regenerate that geolite we have to add NaCl. If you add that NaCl then the geolite will be regenerated. Let me explain by taking some diagrams here. See here how we convert that hard water into soft water in ion exchange method by using that geolite. So geolite means hydrated sodium aluminium silicate is called geolite, simply written as NaZ. So this is the NaZ. So that circle shows the Z and red dot shows the Na plus. So here this is the geolite. So here I am taking hard water. It is a permanent hard water. So in that hard water we have calcium +2 ions and magnesium +2 ions. So that geolite can remove that calcium +2 and magnesium +2 ions. Then the hard water is converted into soft water. So here I am taking that hard water. So when that hard water goes through the geolite, what happening here, that zeolite remove that calcium plus 2 and magnesium plus 2 ions, and the sodium plus ions enter into the water. So the water comes down here. Then we can collect that water in a beaker. So in that beaker we have soft water, because in that water there is no calcium plus 2 and magnesium plus 2 ions. In that water there is only Na plus ions. That Na plus ions comes from the zeolite, because that Na plus ions are replaced by the calcium plus 2 and magnesium plus 2 ions. And during that process the zeolite will consume, because that Na plus ions replaced by the calcium plus 2 and magnesium plus 2 ions. See here, so that Na plus, that red dots replaced by the square. The square shows the calcium plus 2 and magnesium plus 2 ions. So here that Na plus ions are replaced by the calcium plus 2 and magnesium plus 2 ions. And here we can regenerate that zeolite by using the NaCl. If you add NaCl, then that calcium plus 2 ions and magnesium plus 2 ions are replaced by the Na plus, because in that NaCl we have Na plus and Cl minus. That calcium plus 2 and magnesium plus 2 ions are replaced by the Na plus. Then the zeolite will be regenerated. So here this zeolite can useful to further process. Let me take the reaction. So here I am taking zeolite, NaZ, it is a solid, and that zeolite react with hard water, means in that hard water we have calcium plus 2 and magnesium plus 2 ions. So it is a aqueous. So this is the hard water, and this is the zeolite. Then that Na plus ions replaced by the calcium plus 2 and magnesium plus 2 ions. So here I am taking Mz2. Mz2 means it may be magnesium Z2 or calcium Z2, and plus Na plus. So it will give Na plus ions. That Na plus ions are present in the water. So due to that Na plus ions, the water will not get any hardness. So then this water is called soft water, because in that water we don't have any calcium plus 2 and magnesium plus 2 ions. So balance that equation. Here we have to take 2, because here Z2 we have to take here 2. Now here I am taking 2 sodiums and 2 sodiums. Now it is a balanced equation. And next to, during that process, that zeolite will be consumed. We can regenerate that zeolite by using the NaCl. So let me take MgZ2 or calcium Z2. MgZ2, this one, or calcium Z2. It is a solid, and plus we have to add NaCl. NaCl gives rise to, then that magnesium and calciums are replaced by the sodium. So then here NaZ, it is a solid, and plus magnesium chloride, calcium chloride, MgCl2 or CaCl2. So it is a aqueous. Now this is zeolite. So that zeolite is regenerated. So this zeolite is useful to further process. And balance that equation. So here Z2. So we have to take here 2. Now the sodium become 2. So here we have to take 2, and chlorines 2, chlorines 2. So now it is a balanced equation. So this is the ion exchange method. So in that ion exchange method, we can convert that hard water into soft water. Next, fourth one, synthetic resins method. This synthetic resins method remove all types of cations and anions present in the hard water, and the resulting water is called demineralized water. Demineralized water or deionized water or distilled water. So in this synthetic resins method, the hard water is converted into soft water. So that soft water is called demineralized water or deionized water or distilled water. And this method is superior to the zeolite. It is superior to the zeolite. And resins are high molecular mass of organic molecules. High molecular mass of organic molecules. Here the resins are two types, cation exchange resins and anion exchange resins. Cation and anion exchange resins. Now let me draw that diagram. See here, this is the cation exchange resin and this one is the anion exchange resin. From this way, the hard water enter into the cation exchange resin and then water enter into anion exchange resin. Then the hard water convert into soft water, and here we can collect that soft water. So resin is a organic molecule. So this is the cation exchange resin and this one is the anion exchange resin. So during that process, the cation exchange resin and anion exchange resin will be consumed. So to regenerate that cation exchange resin, we are adding the acid, dilute HCl or H2SO4. And to regenerate that anion exchange resin, we are adding dilute NaOH base. So here we are adding acid to regenerate the cation exchange resin, and here we are adding base to regenerate that anion exchange resin. Now let us see what happening in cation exchange resin and what happening in anion exchange resin. So here first of all I am taking in cation exchange resin, in cation exchange resin. So see here what happening in cation exchange resin. So the cation exchange resins consist of hydrocarbons attached to acidic group. Hydrocarbons. So let me take R group. It is a hydrocarbon group and that group attached to acidic group COOH. I am taking acidic group COOH. So this is the cation resin, and now here we are adding hard water. So here we are adding hard water. The hard water contain calcium plus 2 and magnesium plus 2 ions. So that calcium plus 2 and magnesium plus 2 ions enter into resin. So here in that cation exchange resin, that H plus ions are replaced by the calcium plus 2 ions and magnesium plus 2 ions, because here the hard water enter into the cation exchange resin. So in this resin, that H plus ions replaced by the calcium plus 2 and magnesium plus 2 ions. So let me take that. So here that calcium plus 2. Let me take that calcium chloride or magnesium chloride. And here I am taking same group RCOOH and plus calcium sulfate or magnesium sulfate, because we know that the permanent hardness is due to the chlorides sulfates of calcium and magnesium. So here we are taking chlorides of calcium and magnesium, and here we are taking sulfates of calcium and magnesium. So this hard water react with cation resin. So here that H plus ions replaced by the calcium plus 2 and magnesium plus 2 ions. So let me take here RCOO taken 2 times, and here instead of H we are taking calcium or magnesium, and here also same RCOO taken 2 times, and instead of H we are taking calcium or magnesium. So here calcium or magnesium, and now plus, so it will give H plus ions. So here H plus, and plus it will give chlorides Cl minus, and here it will give H plus ions plus H plus ions, and plus it will give sulfates SO4 minus 2, means that calcium plus 2 and magnesium plus 2 ions are stopped at cation exchange resin. Here the hard water goes through the cation exchange resin. So at this cation exchange resin, the calcium plus 2 and magnesium plus 2 ions are stopped, and the remaining water enter into the anion exchange resin. So that water contain H plus ions and which one, Cl minus ions and SO4 minus 2 ions. These ions are present in that water, so that water is enter into the anion exchange resin. Now let us see what happening in anion exchange resin. So let me take that. In anion exchange resin, so this anion resins consist of hydrocarbons attached to basic groups. That cation exchange resins consist of hydrocarbons attached to acidic group, and this anion exchange resin consists of hydrocarbons attached to the basic group. So let me take basic group here, hydrocarbon R, and now here balance that equation. So here 2 R, so let me take here 2, and here also 2, so let me take here 2. Then the hydrogens 2, so let me take here 2, and here also 2, and here chlorines 2, so let me take here 2. Now it is a balanced equation. So anion exchange resin consists of hydrocarbons attached to the basic group. Hydrocarbon attached to basic group NH3OH. So it is a basic group. Hydrocarbon attached to basic group. So let me take another one, or NH3OH. So here after reaction, the water enter into anion exchange resin, and In this anion exchange resin, the OH minus ions exchanged with Cl minus ions and SO4 minus 2 ions, because in that water we have H plus ions, Cl minus ions and SO4 minus 2 ions. So these ions are enter into anion exchange resin. So in this anion exchange resin, so that OH minus ions are replaced with the Cl minus ions and SO4 minus 2 ions. So let me take that reaction. So here that Cl minus ion or NH3 and this OH replaced by Cl minus. So here I am taking Cl plus and OH comes out. So here OH minus. Now here plus SO4 minus 2 ions. SO4 minus 2 is raised to, and here R NH3. So this OH minus comes out. This OH minus ions are replaced by SO4 minus 2. So let me take here, taken 2 times and SO4 and plus this OH minus R comes out, OH minus. So this is the reaction occur in anion exchange resins. Now after reaction, what the ions are present in that water? Only H plus ions and OH minus ions. So here in this water, what the ions are present? Only H plus ions and OH minus ions. And combining of these two ions, the H2O will be formed. So here that H plus OH minus gives rise to H2O. So in this water there is no calcium plus 2 ions and magnesium plus 2 ions. Then this water is called soft water. So then the soft water collected here. So here in this synthetic resins we can convert the permanent hard water into soft water. And during the process, the cation exchange resin and the anion exchange resins will be consumed. Then we can regenerate that resins by using the acid and bases. If you add dilute HCl or H2SO4 to that cation exchange resin, then the cation exchange resin will be regenerate. And if you add dilute NaOH base to the anion exchange resin, then the anion exchange resin will be regenerate. Let me see that reaction. So regeneration of resins. First of all, regeneration of cation resin. By adding dilute HCl or H2SO4, cation resin will regenerate. Let us take that reaction. See here, we are adding dilute HCl or H2SO4 to the cation exchange resin. So here in this, after reaction have RCOO taken 2 times calcium and magnesium. So this one will react with dilute HCl or dilute H2SO4. Let me take that reaction. So here RCOO taken 2 times calcium or magnesium. Then it will react with HCl or H2SO4, gives rise to RCOOH. Then the calcium or magnesium are replaced with the H plus. So then here we will get hydrogen, and plus this calcium and magnesium plus 2 ions are comes out. So then Ca plus 2 or magnesium plus 2 and plus Cl minus. So this is the regenerated cation resin because it is a hydrocarbon of acidic group, hydrocarbon attached to acidic group. So it is a cation resin. And balance that equation. So here 2, so let me take here 2 and 2 hydrogens, let me take here 2 and 2 chlorines, let me take here 2. Now it is a balanced equation. Next, regeneration of anion resin. In anion exchange resin, what we have after the reaction, RNH3Cl and RNH3 taken 2 times SO4. So this one will react with the NaOH. We are adding NaOH. If you add NaOH, then the anion exchange resin will regenerate. So let me take these two. So here RNH3Cl and RNH3 taken 2 times SO4. So these can react with NaOH base. Then the anion resin will regenerate. So here that Cl, the Cl minus replaced by OH minus. So here RNH3 OH and plus the Cl minus, and here Na plus will give NaCl, and now here that SO4 minus replaced by OH, then we are getting RNH3 OH plus sodium sulfate Na2SO4. Now these two are anion resins because these two are hydrocarbons attached to basic group. Hydrocarbons attached to basic group. So these two are anion resins. So the anion resins are regenerated. So this is the regeneration of resins. Regeneration of cation resin and regeneration of anion resin.